Let's see how you can create a CAM mechanism in Creo Parametric. As you can see, we have this CAM, and this is the follower. This section is the support, and let me just close here. Let's create those assemblies now. I'm going to insert all those parts. Now insert assemble. First is ensure you have preview selected. Insert this like that. Okay. Again, let's go to support. Open. Okay. Follower. Open. Then say okay. These are the parts we are going to use to create our CAM mechanism. And before I start using the constraint, I want to create an axis that is the intersection of this plane and this. Therefore, select an axis, this plane and this plane where they intersect this axis. This axis will define how our CAM will be rotating. Then the follower will be moving along these two planes. This axis defines vertical motion. This axis defines rotary motion. Therefore, let's start with this one now. Right click here, select here. Instead of using automatic, I want to delete and select pin. Pin means my part can rotate, and for the component, hide this, select this axis to rotate onto this point. And for the translation, ensure that this plane and this plane, they are coincident. If you say okay, now if you try to rotate your part, it can rotate. This is our CAM. Okay, and before I proceed, I want to make my CAM shorter. Instead of having 250, make it 150. Yeah, like that. You can see. Then let's go to the follower support. Then the follower support will be using this axis here. Therefore, let me hide the planes first, this axis and this axis. Therefore, right click here, select. I want coincident between this and this here to be coincident. And again, I want a distance between, let me now show the planes, between, let me first hide this, between this and this. I want some distance here. That is, I can maybe use 160 like that, and then you can show this. Therefore, this one will be fixed on it will be, this one has no motion. Then we have our CAM follower. Again, this axis here coincident. Ensure we select this to be coincident, this to this, like that. Then to avoid rotation, if you say okay like that, if you select this follower, it can easily rotate. Can see, we don't want any rotation. Go back to the follower, select here new constraint, make it coincident, this plane to this plane. Okay, now if you drag this up, it will be moving like this, while this one will be rotating like this. Therefore, fine, let's go back up. Okay, then let me hide this datum geometry, and now go to application. You go to mechanism. For the mechanism, we need to define CAMs. You see the CAM section here. We have now this menu bar where you define CAM1 and CAM2. For these references, we won't define this because we have already defined our constraint in assembly level. On the CAM1, you just select auto select to just select one surface, then it makes a loop. If you select auto select, If you select one surface here, it continues and it makes a complete loop. Go to cam 2. It's not complete. Cam 1 is not complete. Okay, again here, auto select this. Say, you can see here, say okay. Then go to cam 2. Again, auto select, ensure this one is visible. Select here and then say okay. Once these lines, you should have something like this. Once you say okay, they should touch. If you go to the front view, you can see now they are touching. And if you try to drag this, you can see now they are, let me try to rotate this instead. You can see it is exhibiting the cam motion. Then let's now insert a motor onto this here to drive our cam. Select motor onto this connection. Then for the profile, I'm going to use angular velocity of 60 degrees per second, and it is a constant. You can use ramp, cosine, polynomial, can have table define, can define table parameters here. But for let's go with the constant here, say okay. If you go to the analysis, because you're just interested on the motion, we're going to use only kinematic to see how velocities and acceleration are being generated. Kinematics about motion, dynamics is about forces. When you select dynamic here, you can get reaction forces, you can get the stress distribution of the part. For now is a simple mechanism, and say run. You can see once you okay, now you can go front view and let's see playback and play. Let's play and see what happens. Yeah, front, back. You can increase the speed here a little bit. You can have reverse direction like that, then reverses. Yeah, that's how you can perform cam mechanism in Creo Parametric. They can also capture this video using capture and save as MP4. Okay, and thank you and stay tuned for more.